initialize it. It takes some time to initialize it. You wait till it tells you everything is okay. So look on the panel. Look on the panel and see. You see it has given everything and says status. Okay.
Yes, go and see. It will show that if the installation is okay before we can proceed.
Okay. So after everything, it says now we can continue. Then you open the app, which is this one. I wish I could bring it somewhere here. Okay. So this is the app. We have two. One is the database, not that one. Compass. So now the app is open.
So the app, the various applications, the various type of tests will be performing. They are there, then we select. Okay. Yes.
So there are several of the tests. You know, viscosity curve, flow curve. There are several of them. Okay. So today, I want us to analyze ketchup, a sample that we received. Okay, so we analyze ketchup, and you'll be looking at the flow curve and then the viscosity curve. So we select the flow curve. Usually I prefer the log. Okay. But before that, you have to come to this and then to do the initialization. Okay. The tests are here, alright, but then if you don't do this one, it will not work. So you first have to initialize it. You wait till initialization is done. So the first was initialization for the instrument, and then now you come here to do another initialization. Okay. So it is done. It is done.
You just wait for it. When it's ready, you will see.
Okay. So you open the temperature hood and then set the probe. I'm using the parallel plate. And probably you can ask Prof, why not a code? But then the parallel.
Yes, please continue. At the moment, what will happen is we will continue with the. Now we are inserting the probe.
Now inserting the probe.
Yes, continue with the process. When you have a question, you ask and we will explain it. This geometry to insert, there is a mark there that needs to be in line with the probe. If not, it cannot enter. So that is the technicality of it. So now it has been,
the probe is inserted, so you set zero gap.
The zero gap here means we will now bring the probe down to meet the lower geometry. So that there will be no space in between. So we zero the gap. When it's up and we now apply the sample, the space is occupied by the sample. So any measurement we take now will be due to the presence of the sample. That is why we zero the gap first.
What's the diameter for the plate?
Okay. The plate has a closed diameter on it, and you will see the diameter indicated at 49 point something millimeters. So that is the diameter. And then the cone one, the angle of the cone is 1 degree. Okay, so those details are on it.
So, please, why are we using the parallel probe?
Okay, from the theory yesterday, we learned different samples and the type of probe which is suitable, isn't it?
Yes.
And now this is more or less a paste. Yeah. So the power plate is suitable. you produce the complaint for viscous system.
Okay. So once you see this highlighted, you know, initially when I clicked on the initialize, it went faint and then highlighted. Then I continue. Within the zero gap tool, it went faint and then now it has now. So when you see that, then you can continue. When it highlights.
Now that it has been zero, you will look at the control panel here, and every reading here will be matching the specifications for the probe. So we now see the gap as what, 1 millimeter. At the moment, well, we have not reached into temperature and so on. But it's telling us the status is what? Okay, the plate being used is BP50, which is correct as this plate. So the machine is able to sense the right probe according to the software. So we are on course. We just want to be sure that the software has recognized what is ongoing, because every measurement is not going to be done by the software. And it's going to take into account it is parallel plate you are using, and at this point it is zero gap. So now to take it up, you just click on the up arrow over there and it will move up. On the machine, we can press the up and down here, but because we are using software, it's better we deal with the computer than doing the manual. The manual is done if you were not having the computer. So I will now press the up. So we wait to go up now. So after that, before we apply the sample.
You always have to check on the screen whether it tallies with what the system has recorded or recognized.
Yes. So the control panel here, we always check when everything is okay before. If there is a problem, it will indicate.
The app, you have two arrows. So you are always, is it the right one?
Always the right.
Not the left arrow.
Okay, so now
Should you mistakenly click on the left one?
nothing will happen.
Okay.
Okay.
They all work.
Okay.
It's just that when you do manual, you are pressing, that will determine the movement. This one too, you press like this, it will move to the end.
Okay.
But if you don't want to move to the end, and let's say you want to move this to the end, you press that, it will continue to the end. But I don't want it to go all the way to the end before bringing it down again. So to a certain level, you use that side, then it will increase to a certain level that you can
sample
slide. So that is the meaning.
Okay.
Yeah.
And sir, please, would it reject a different code?
Huh?
A different probe?
At the moment now,
For example,
everything
if
we
you
are
had
doing,
put the code instead of the parallel plate.
it will not reject, but now we are using this code. This is what is recognized. If we change now, we have to zero it with a new plate to capture what is the new one.
Okay, like you reject it. Why is it all the way?
Wait, so people ask questions that are of engineers' interest, not analysis. The length of this probe and so on, it depends on the type of probe you have buying the machine. So one day you might not use this machine. So the length of this probe is not something you must constantly use. Do you understand? The rheolometer I used before is not like this, but the concept is the same. So if you are interested in the length, the information about the probe, we have the details we'll give you. Okay? Yeah, from the specifications of the supplier, the length is all there. I have not bothered to keep this length and things in my head.
You didn't know that.
So you see, with this product development coming up, when someone brings a sample and the lab technician is not so familiar with that kind of material, how best do you know whether or not to use the cone or parallel?
Yeah, so the technician is not alone. We are working with a team. So whatever it is, will be sorted. And the technician is also not what we call intelligent person. If you don't know what to do, you will consult to do. You understand? This man here has not done rheology in the past, but I can give you assurance that he's more competent than the people who have done it before. You understand? Yes. Yes, he's a very experienced people. It's like some people, let's say even children, you don't know computer, you know computer more than them, but they are faster than you. You understand? So we don't play with the technical versus academic knowledge.
But then can you use the just flow, see how
Yes.
having the material to know because
Yeah,
the
yes, in
different
fact.
viscosity levels give the different, isn't it?
That is what I think.
We are going to do that. We'll do water, we'll do solution, do different things.
If it
For you
is
to
thick,
appreciate.
you use the parallel.
Uh-huh.
If you have a very viscous solution, you use the parallel. If it is less viscous, then you use the cool.
Okay.
Also, so with what you just said, does it also mean I see the settings here as viscoelastic? So if you are using, we understand that the rheometer can set the elastic as well.
It will do
So you have to change
these two
from
pro.
viscoelastic to elastic if you are doing like a more solid.
Yes. The more solid, we use this BP, power plate.
Yeah.
If you have a liquid like
Water.
water, affecting solution or various things, yeah, there's no big
And the
deal.
profile on the screen, I see viscoelastic.
Yes,
So
don't
the
yes.
profile also changed to elastic.
No, unless you change it.
Okay. I mean,
We have not
change it
changed
based on
way
based
on
on that.
We are moving step by step. At the moment we are loading sample. When we go to run the test, we will select the test. Okay? It's like we have been shown how to turn on machine. We will now move to the next step where you select the type of test. Do you get it? Yes.
Jumping
So
the
they are
gun.
running. Please, what Firma was asking,
Yes.
just explaining that for instance, if you get the sample like honey with granules, chunk of granules or something within, how does it guide you to? Do you have
Yes.
to blend or maybe the product has to be like that?
So this product is a mixture.
Yes.
Have solids, lumps, or things inside, particles in it.
Yeah.
So that is why ideally is the power plate in this case more suitable, because the space in there is. We will now have to go into theory. The cone is not flat; it's certain angle. But this one, whatever is under it, is the same level everywhere. So anything under is equally catered for by the structure of the materials in there contributing to the deformation.
Yeah.
Uh,
So that's how you put the sample on. You don't weigh.
No.
Okay.
the main thing about the sample here is that it should be enough so that it will cover under the geometry, the upper geometry when it comes down. So somehow enough so that when it comes down and it's spread, you always create a mess. We will trim it again, remove the excess so that it's enough. So you don't have just a little under, where meanwhile it's taking into consideration the whole circumference or diameter of the car. That is why if you don't have enough sample, we go for a smaller probe with a smaller diameter. So a small drop is enough. But now this diameter we have, you need enough sample too. So you always get a quantity that can be enough to cover the surface of the geometry. So now when it comes down, we all see it. So sometimes this is a difference in technicality, whereby somebody will know the exact quantity that will be enough to be there. Then, because we can't predict that for all materials.
Yeah.
If I use water, the volume of water I put is not the same as if I use tomato paste. So it's from experience that you will know what quantity to put there, and then we can repeat it. Now, when it's too much, it will spread and will trim the edges. When we get to that, it will also tell us, I think we have not shown the full control power.
It will come.
Good.
Okay.
Yeah.
So now it's telling us to trim the sample.
So it's a trim sample.
So it is there that takes out.
So So this is the mess part of it every time, cleaning and yeah.
When you bring okra samples, then you have a lot of work to do.
Yeah. And so at this case too, this is where experience over time will be helpful so that you know the quantity you put there, then you don't have too much trimming to do. Yes.
I don't know, is it possible that you put small there, drop it? If it's not enough, can the system tell you to add more? As in later again, add more?
For instance, when you lift like that, you have caused some deformation. Yes, you have disturbed the system. So ideally, if it were things less viscous, you can just use pastel paper, this one, with soak it, then you can inject it through the side to fill. But when it is a concentrated thing like this, it's difficult to push it in there. So you always get enough. And this is our first time with this sample and with a group like this. So what will happen is, over time, you will be able to get and know what quantity you put there and place in the middle and do. Yes.
After cleaning for some time, you
It's like learning how to prepare bamboo. The first time you get lamb, the second time.
The first time somebody prepared bamboo, the whole pot and then the cold pot, the chocolate, everything on the floor. The second time was perfect.
Okay, so now we are still streaming.
somebody has to say.
She don't know if the sample does not come into direct contact with us. If you put it in on a filter paper before putting it
No, don't need to put on filter paper and put on the two surfaces are what is meant for the measuring. The machine is sensitive at those surfaces. Once you bring a filter paper, then you don't have contact. It's like if I want to touch your skin, there's different feeling now when you have laptop on your body. So the same way, you don't bring anything there. There are sensitive surfaces to detect the viscosity.
We are done with this side. We can now let it go. Okay. Now we have to select the test tube.
So which test are you running?
So basically now from the theory yesterday, what is of interest when we look at ketchup, this ketchup sample, so that it's not that we bring anything and then you want to run anything. Some things viscosity is necessary, some too is not viscosity that you are interested in. But this is a sample of interest, ketchup. What we need to know about ketchup that is important to the developer or for product quality and so on. So that is what we come and measure. Other than that, you come and just measure things, it's not necessary. So you learned yesterday, yield point is very important for ketchup. You get it? So we run a shear stress versus shear rate, and this will be able to see the flow based on the appropriate model, determine the what yield point or yield stress. Okay. So that is what is selecting. So when we run it, you will see the curve and the model calculating at the yield point value.
What's the yield point? Sorry, yesterday I wasn't a good
Okay,
student.
sorry
Yield
now.
point.
For things to flow, you need a minimum force to apply before it can flow. If not, it will never flow. It's like toothpaste. If you don't press certain amount, it can never come out. Most ketchup too, once we pour, you need to press or shake before it can pour. So that tells us. So now, this is somebody's, Dr. Kodo's sample. It's a research sample anyway. Very soon, the paper will come out and we're happy to see that this ketchup has different stabilizers inside. There's a control with xanthan there's another with pectin, there's another with starch combinations. So,
And you are doing that to help the consumers to how to easily pour the ketchup, or what is the purpose?
Well, okay. Let somebody know.
Maybe,
So
yes.
one is what he mentioned, xanthan gum, not very available. But if I can use starch, and it will still do the same work, or reduce the amount of sand and increase touch, and still achieves the same purpose. Then is fine. So industry wouldn't have so much problem. They always have to get some time.
Please, what type of starch are you using?
Oh, please. That one is listen. We want to see how to do the measurement and people are interested. But we will discuss that one. Okay. Yes. Okay, we'll get it back. I will send a list to the appreciation letter. I think you should write appreciation letter. Somebody can just copy it to people who said, but you can't rely on it. So please, you know what? We have plenty time to do theory discussions and explanation. Those ones, even without the machine, we can do. But the machine thing is different, okay? So let's focus on the test, run the test. When we get the result, we will discuss. If not, we will become champions in the theory. Then, I'm happy you are doing the thing yourself so you can have a feel that it's possible. So we enter details about the work we are doing. The operator, sample name, description, so that the machine will capture those details. When you print the result or export the result, you know what sample it is for reference. This can be connected to a printer to print the data, but the software to the data is there. You can go and open, export to Excel or whatever. But if you don't label it, you won't know which sample is what, whose data is which. Yes. So now she is calling this one ketchup sample. Ketchup is just one word. Then KXC. All right. It's just for a trial. So
So when it gets to around 25, you can skip it.
So this is where if we can change the temperature, but for now it's 25. We'll put 20 as a standard temperature. Yeah, you can put if you want to. It doesn't change anything. All right. For now, we don't worry about this. We are just demonstrating. Okay. So what is happening is that, can we see the machine here? Madam Johan. You see that here the machine is 24 and this is 25. Until it reaches 25, you cannot continue because you want to reach the temperature you set for it. So that from experiment to experiment with the same temperature must be attained to take the measurement. So it means at the moment this has yet to reach 25. It's like the, even though the air conditioner says 16, this room is not 16, that kind of thing. So, started measuring. So what is happening now is I started, we see like with the speed, we to start small, and increase to the higher speed range. So the data will start collecting, so we reach that. So now we have a shear stress versus shear rate being plotted. After that, it will fit the curve according to one of the model, either Bingham, Berkeley. This one will use Berkeley to give us the curve fitting, and then we get the yield point result. So this is telling us viscosity against shear rate, but this is shear stress against shear rate. It is from here we determine the yield point. But at the same time, is giving us a picture of what is happening to viscosity as you increase shear rate. Do you get it? So it's decreasing, breaking down. But in this situation, we will now see what minimum force is required for the flow to start. So from here by the eye, you can see the minimum force so far, but the curve fitting will give it the exact. People have developed various models to do this calculation. The calculation shown to us. So the thing is done, result. So the details is there. If this was connected to a printer or online, you can print this screen. But we have the soft copy, okay, which can export to Excel. The data is there, will open, you can have access. So now you will see that all the parameters entered are there. The rheolometer used LCR 92. There is a type of rheolometer. The probe tool is PP50 power plate used. So the sample information, blah blah. Now we see viscosity is given as 1.72 millipascal. That is the viscosity of this sample. Okay. Then when we go to the next one, is given as that tau 0 is the yield point. So these are single point result. Then the graph. Scroll this down.
So it gives the average viscosity.
Yes, so the machine has done everything, calculated everything for you. Unlike going manually to calculate things, no. Software has done the job finish. Data is also there. This has been plotted as a curve, but the data is there. This one you can't do anything, but the other one you can plot it yourself. Maybe instead of red, you make it green or blue, those shape. That is the data processing. We will open that. So from here, you see the original curve showing the viscosity as we plot the shear stress versus shear rate. Now the red one is telling us that the Berkeley model was used to model this equation. So based on that model, the yield point at zero shear rate, what is the shear stress? The beginning there, that is 26.989. So that is the yield point result. So imagine we have this sample of different treatment. You have different yield point results, or you can print different graphs to compare. And then, okay, if I use xanthan alone, what is the result for viscosity of that sample, and what is the yield point? If I now use xanthan and starch or starch only, so and so, whatever, depending on your research formulation. Okay, so we get the result. So on this note, this is what we get. The rest is interpretation.
So that's the viscosity.
And then you
So-
can also come here and see the two.
Yes. So these are the things already plotted. This is what students like, but in the end, you're not the best. Yeah? People like already plotted graph. You know?